Everyone, let's look at number 24 in section 5.7. We're going to use the change of variables formula to evaluate the following definite integrals. So change of variables means we're going to do substitution, being careful to change our limits of integration, and then to evaluate the resulting integral with the fundamental theorem of calculus part 1. So what's our substitution going to be? Well, we see x squared plus 6 inside the cubing function, or really 1 over u to the third, or u to the negative third power. So I'm going to choose my u to be x squared plus 6. So the derivative of x squared plus 6 is 2x, so du is 2x dx. I see I have an x dx. I'm going to balance that out by multiplying both sides by 1/2. So my x dx is 1/2 du. I'll have 1 over u cubed. But don't forget, change the limits of integration, right? The lower limit, x is 2. If I let x be 2 here, I'll get u to be what? 2 squared plus 6. 4 plus 6 is 10. And if x is 4, I get 4 squared plus 6. 16 plus 6 is 22. So when we do the change of variables, the integral now, again, the x dx, right? X dx becomes the 1/2. Pull that out as a constant multiple du. X squared plus 6 is u to the third, u cubed in the denominator. Remember, the lower limit of 2 became 10, and the upper limit of 4 becomes 22. Just rewrite this now. 1 over u cubed is u to the negative third power. And notice the integral has become something we can do. Substitution allows us to make the integral doable, make it simpler. And in this case, power rule, right? Add 1 to negative 3 and divide by that same number. Clean this up a little bit, right? 1/2 times 1 over negative 2 is negative 1/4. U to the negative 2 becomes 1 over u squared. So here's my antiderivative. And notice I'm not going back to the original x variable. I'm just staying in the u world, right? Because these limits we changed, and that's the way it should be. You cannot have x limits of integration here with u variables. So I'm going to plug in u is 22, and then minus this negative 1 over 4u squared, where u is 10. So we get some big fractions, at least big denominators of fractions, small fractions actually. So we are able to find a common denominator, and then we're able to add, well, minus a negative, or subtracting, but minus negative becomes positive. And adding this negative fraction to this positive fraction gives me this, which simplifies down to this. Both of these have a common factor of 16 that we can factor out and divide numerator and denominator by that. You can use technology to help you with that as far as simplifying it down here, but make sure you show completely your substitution and the evaluation of your antiderivative here. Okay, hope this is helpful.